friends, students, and enthusiasts. So today we have come up with another topic that is very, very important for project makers as well as for electronics and communication students. That is, who are studying or doing project on embedded system, they should know what is UART, SPI, and I²C. So these three, that is UART versus SPI versus I²C, it is a protocol that is, we call it as a communication protocol. And which one you have to use, we are just making a difference between all the three protocols, and we'll understand also. As well as we will have a small interview preparation and interview series and prepare for your technical interview. So let's start with the first slide. So today we are going to understand three very important serial communication protocol used in electronics and embedded system, as we have already discussed. One is UART, UART. Second is SPI, and third one is I² or I²C, we call it as. You will find these three protocol in Arduino board. You have seen, because we study to do any project starting with the Arduino. So Arduino board has these three protocols. ESP32, again, same embedded system board. Raspberry Pi, what we have done in the previous classes. Sensors, display, RFID modules, and many other devices. By the end of the video, you will understand how they work, their wiring, advantages, and disadvantages. We'll discuss about the advantages mainly, and most important, when you use each of them. So we'll be discussing what are the components or what are the modules which will be working on this: display, SD card, GPS module, Bluetooth, right? And other sensors. These all work on this three protocols. All right. So let's take first protocol, that is UART, Universal Synchronous Receiver and Transmitter. The full form is Serial Communication Method, right? Which is not asynchronous frequencies. That is point to point. So here, how you will identify the UART sensors or module, whatever will be written here, TX and RX, these are the two important indication on the module or any of the devices you have to see. That is TX and RX. If it is given, then it is a UART. So the TX is connected to RX. If it is a two devices, A and B, then one TX is connected to another RX, and one RX, that is device A, RX is connected to device B, TX. Ground will be common here. Correct? Right. So UART does not normally require a clock wire or clock devices, clock pulses, must agree on parameters such as baud rate. That is very important. What is the baud rate? You have to select. Usually it will work on 9600 baud rate. That is the data rate. We call it as 96008N1. That is one stop bit, we call it as, right? Number of data bits, parity, stop bits, just now we have discussed. So a common configuration is 9600 baud rate. That you have to understand. All right. So TX is connected to RX and RX is connected to TX. That is very, very important. How you will identify the TX and RX, etc. Now we'll go to the example part where we use it. UART is commonly used for GPS module, GPS, right? That is communication module where we use GPS signal. That is GPS module, GSM module, right? If you are making any project based on GSM module, they will be using UART only. Bluetooth module also uses a short range communication module, also uses the UART communication. Serial monitors are very common between the microcontrollers. All right. So this is about UART. Okay. Now the second one is SPI. Now we'll discuss about the SPI communication. Okay. Now serial peripheral interface. SPI is synchronous. Please remember the previously it was asynchronous. Now serial peripheral interface is a synchronous communication protocol and is generally faster than UART and I²C. That means this is very, very for speed. If you're looking for the data speed, then you have to see for SPI peripherals or SPI based sensors and modules, right? So here SCL, SCK, that is the two type of clock pulses are there. MOSI, that is master out, slave in. MISO, master out, slave out. SS chipset, that is select the chipset, then master and clock pulse will be there. Okay, so these are the main thing. Mainly how you will identify SPI, MOSI, and MISO, right? Master out, slave, and master in, right? Master in, slave out. It is taken like that. So wherever you see this MOSI and MISO, you will understand that it is a SPI, that is serial peripheral interface. All right. Okay. Now we'll go to SPI can communicate with multiple slave device, but typically each slave needs its own chipset line. That is, chipset line is CS. Just now we have decided that CS chipset line will be separate. That is CS. For example, SPI is widely used with the example of this thing. That is where it is used. SPI is widely used with TFT displays, especially displays, TFT, the older type of display, right? OLED displays, the latest one. SD cards, okay? RFIDs, that is RC522. We do a lot of project with this. Flash memory, high-speed ADC and DAC devices. Example I've given, that is BMP280, one sensor, very common sensor. BMP sensor, we call it as, that is temperature and pressure sensor. There also we use the same communication, that is SPI communication. Now, what are the limitations for this, especially SPI? Requires more wire than I²C, especially with the multiple devices. When the multiple devices, so your number of wires will be MISO, MOSI, clock, SDA, CS, all these connection is to be given. So this is the drawback or limitation for SPI communication. All right. So now we'll go for I²C. That is, what is I²C? Inter-integrated circuit, we call this. Please remember, I²C or I²C is the same communication protocol. Okay, inter-integrated circuit, we call it as. I²C is also a synchronous. Please remember, it is not asynchronous. It is a synchronous serial communication protocol. Serial communication protocol. It used only two lines, two wires will be there. One is called serial data, that is SDA, and another one is serial clock, that is serial clock we call it SCR, we call it as. So suppose one this thing is there, you can connect number of components which will have different address that we will discuss. Master to sensor 1, master to sensor 2. Then you have SDA sensor 2 and SDA sensor 1 and 2. Likewise, different sensors you can connect with SDA and SCR. It can be OLED, it can be sensor, it can be connected to the same line. But multiple devices can share the same SDA and SCR line. Each device normally has address allowing the control to communicate with the particular, you call it as particular device. Okay, so address will be different. For example, OLED has 0x3C. It can be 3C, 3D. The next sensor, it should be different. It should not be 3C. That is, we call it as address. Okay. Another sensor, another address. I²C therefore saves GPIO pin when several peripherals are connected. Only two lines, several peripherals, single line. We can connect to it. So example are the latest one, SSD 1306 display. We use it in our projects. BME 280, just showing you temperature and pressure sensor. BMP 280, approximately the same function. So BMP 280 also, RTC modules, EEPROM temperature sensors, they work on the same protocol. Okay, I²C. So what is the limitation for this? Generally slower than the SPI. That means SPI connections are more. Here the connections are less, but slower. The data rate, transfer rate is little slow. Requires appropriate pull-up register and SD and SD. What do you mean by pull-up register? From supply, from data pin. That is, if the signals are there, from there to supply, there will be a register. That is, we call it as a pull-up register. It can be 4K, 4.7K, 10K. That is, we call it as it requires a pull-up register. All right. So quick comparison is there. What you have to compare, that is UART, SPI, and I²C protocols. So types asynchronous, synchronous, and synchronous. That is SPI and I²C synchronous, synchronous, right? Main signal here, what you have to see, that is very important for everybody. That is main signal in UART, TXRX, SPI, it is MOSI, MISO, CS, and SCK. Whereas I²C, it is two only, that is SDA and SCL, right? In UART and I²C, only two connections. But the fastest is SPI. Okay, clocks. What about clock pulse? The clock pulse here, we don't use clock pulse in the first case, that is UART. Yes, we in SPI and in I²C, because CS and SCK are there, so we use clock pulse. Topology is point-to-point, master slave, multi-device bus, full duplex. Yes, in I²C. Generally, we don't use it in I²C. That is full duplex. Multiple devices limited. In SPI, yes, if we can connect it, and I²C, of course, you can connect multiple devices. So likewise, you have to study what is the common use, UART, SD card, RFID, sensor OLED. These are the usage in UART and SPI and I²C. Easy way to remember UART, simple communication, SPI, speed, I²C, two wire plus multiple device. This is the best way of understanding. All right. Okay. Now We'll go to interview questions. Now, what may be asked, because in just now I've given you the complete idea. Now I will just go for the what may be, suppose you're going for the interview and writing an examination. So what may be the questions which will be asked for this thing? What is the main difference between this thing? That is, what is the difference between UART and SPI? So answer is UART is asynchronous and normally uses TX and RX without a separate clock. SPI is synchronous and uses the clocks along with MOSI, MISO, and chip select signal. Chip select and CS. Okay, so this should be your answer. Let's go to question number 2. How many wires are required for basic I²C communication? So two signal wires, right? Two signal wire, that is SDA and SCL, serial clock and serial data. That is the answer. A common connection also requires a common ground. This is also very important. Both the SD and SCL ground should be common. Okay, right. So question number 3, which protocol is generally faster, SPI or I²C? So your answer is SPI is generally faster than the I²C, making it suitable for applications such as high-speed display, SD cards, memory devices. Actually, performance depends on the specific hardware and configuration. Please remember, this is very important. The performance depends on the specific hardware and configuration. What is the rate of data, rate of transfer? That will depend upon the hardware, what sensor you are using. That is the meaning of it. Okay, right. Next question. What is the purpose of the CS in the SPI? This is very important. CS, that is we call a chip select. CS stands for chip select. Selects which SPI slave device the master wants to communicate with. Okay. When multiple SPI devices are connected, each device commonly has its own CS line. Different CS line will be there if it is multiple. Okay. Right, next question, that is, which protocol would you choose for an SSD 1306 I²C OLED? Okay, it's an OLED, small OLED display, and RC522 RFID module and GPS module. Right, so for SSD, you will use OLED I²C square, I²C or I²C. For RC522 RFID, we use SPI, and GPS, we use UART communication. Right, okay, so these are the questions. So conclusion, what we have drawn. So remember these 3 protocols with 3 simple words. UART for simple point-to-point communication. SPI when you need higher speed. Please remember, SPI when you need higher speed, and I²C when you want to connect multiple devices using only 2 signal lines. Understanding these protocol is extremely important for Arduino, as we have already discussed, yes, Raspberry Pi, and different type of embedded system projects. And they also frequently ask in the electronic interviews. Please remember, in the next video, we will take another important electronic topic so that we will discuss some more things which are important for your curriculum, for your skills of electronics. All right. So thank you and good luck with your interview questions. See you next time in the next video.